Hey everyone, and welcome to this video where I'm going to talk to you about a fabulous new backend that I've discovered this week. I don't know how fabulous it is, but I think it's pretty cool. I discovered PocketBase as a result of watching the super duper Fireship YouTube channel. So if you're not a subscriber to Fireship, I definitely recommend signing up. I've discovered a lot of really cool tools from that channel. And PocketBase markets itself as an alternative to Supabase, which is an alternative to Firebase. And I think it does a pretty good job. I'm going to show you how it works. So first of all, just to get one thing out of the way, PocketBase is based on SQLite, I don't know how you pronounce it, SQLite. And that might sound a bit scary. Like, yeah, I thought that, for me, I thought that SQLite, I'm like not a developer, so I just figured that SQLite was a kind of test database, or like just something you would use for kind of small amounts of data, just maybe on your own application, like an internal application, something like that. But just it was a kind of placeholder for a serious SQL database like Postgres or MySQL. And it's not true. And SQLite is actually a really good database. And PocketBase, for example, when they're defending themselves as a serious backend solution, they would say that they boast that on tests they can handle up to 10,000 concurrent connections, live data connections or concurrent user connections with a like 4 GB 2 CPU server, which is pretty impressive. So that means your backend costs come down quite a bit. And you'll see the way it's set up is very, very simple, very lightweight, very fast. And it does lend itself really well, in my opinion, to Noodle. When I saw this and when I saw the way it was set up, I immediately thought, like, I have to test this out in Noodle. I want to know how it works in Noodle, and it works great. I think I literally spent about maybe 30 minutes, 45 minutes setting up an app that can do creating data, deleting data, and subscribing to live data, which was really exciting. So let's just dive right in and I'll show you a little bit more about PocketBase. So if you want to try PocketBase, go to their website, go to the documentation. They have local versions for like ARM64. I'm using Mac, for example. So I'm running one on my Mac at the moment. I tried running one on Linux, but for some reason, there's some sort of special compatibility issue with Linux running on a virtual machine. It uses some kind of package, or I don't know what, that is not compatible with their version of SQLite, so it didn't really work. But I was able to run it on my Mac really easily. I'm sure on Windows it's equally easy. When you download the installer, it's a zip file. It's not even an installer, sorry, it's nonsense. It's a zip file. When you open the zip file, you'll have PocketBase executable, you'll have a markdown license and changelog, and that's it. And essentially this executable, it's a bundled version of the PocketBase UI interface, the PocketBase server, and the API layer, and the PocketBase database, the SQLite database. So it's all running under the same hood. You don't have to have SQLite running, and then you've got your API thing running that communicates with it, and you've got your front end, like the interface running that on a server. It all runs under the same executable, which makes it very lightweight. It's like 40 megs for the whole thing. And so yeah, you're going to see in general, this is a very lightweight thing that we're using. These two folders got created because I started using it. So you get PB data that's created. So you get like a data.db where all the data is stored, logs that stores information that about creations, deletions, that sort of thing. And you have backups as well. You can set it up to do automatic backups. It doesn't have to be in the same folder. It could be in an S3 server, for example, if you really want to protect your data. So there are ways of taking what might seem like, oh, it's really insecure. It's just a little tiny executable running with all the data inside it. Like what happens if it gets deleted or if something goes wrong? But yeah, you can back it up. You can bring the data back into it using backups, migrations. You can import, export data really easily. So it's actually pretty good and seems to be vetted by serious developers like Fireship, the guy who runs Fireship, for example. So I tend to trust it, but trust it in testing it. Test it out and see how it works and see how you feel about it. So once you've got that there, you just need to open your terminal here and then run this command, PocketBase, so /PocketBase serve if you're inside the folder, and that's it. And literally you just have this stuff come up like, yep, it's running. no problem. You've got your server address, you've got your admin dashboard address, and you've got your API endpoint, all just running immediately with nothing else to do, which is pretty magical. Compared to like Supabase and trying to self-host Supabase. I don't know if anyone's ever tried self-hosting Supabase without Docker. Pretty amazing task. Or even with Docker, like it's you see like tons and tons and tons of dependencies all spinning up, whereas this is just one really simple, straightforward thing. So it's running, say it's running on my local host on port 8090, for example, and we want to get it into our Noodle project. So we open up our Noodle project, we open the project folder. I tend to create a little folder called scripts, but I think like hardcore developers call it SCR. It's the secret word for scripts. Anyway, just call it whatever the hell you want. I call it scripts. So just make a folder called scripts. Remember, this gets deployed with your Noodle project. So when you deploy the project to a folder, the scripts folder will get put into the deployment, and it will be referenced by the app the same way it's referenced here in the editor. So if you're referencing it like /script/ whatever, then that reference still is maintained when it's deployed to a live website, because it's all the files are still there and the same structure is still there. So in the scripts folder, what I did was opened up the scripts folder and I ran this command. Npl install PocketBase npm. So you need npm in your system. Npm install PocketBase safe, and so that installs node modules, PocketBase distribution, and it's the, which one is it that you need? This one, umd.js. So it installs this file, which is the one that needs to run, I guess, in conjunction with other ones to load the PocketBase SDK into your Noodle project. So then you can reference that in your Noodle project and import it into functions. So how do we do that? You copy what they've done here, script src equals, and then you do the path. So this is a relative path. So if you look in my head code in my project, it's /script /node module /PocketBase /dist /PocketBase umd.js. So that loads that JavaScript file into your project as soon as the page loads, because it's in the head script. And then it means that within your app, you're going to be allowed to run any of these setting up PocketBase as a variable, referencing your server, which it would be localhost 8090 in my case. Or if you're running it in your own server somewhere, it would be myserver.com, port 8090, whatever, wherever you've pointed it to in your server. And that's pretty much it. Once that's done, you have the full power of the PocketBase API in here to create things, fetch things. So I've created a test here. So when you load up PocketBase for the first time, it'll ask you to put in an admin email and password. So get that out of the way, make it something nice and secure. And then it'll create you by default a users class, which has an ID, username, email, name, avatar, created, updated. So you can change this, edit this, do whatever you want with it. There are system fields that you can't override, but still you can change fields. So I'm not going to mess with this right now. What you need to know is, the cool thing about this is PocketBase can handle authentication. So it does have auth providers, the same as Supabase or others, or Firebase. You can get Apple, put in your Apple client ID secret, put in your Google client ID secret, et cetera, and let people log in through these different auth providers, which is pretty amazing. And yeah, we'll not go into that just yet. Yeah, auth with the auth too. So I'm not going to go into detail with this because I haven't tested it yet, but this is where you would go. You go into your users collection, API preview. It gives you a whole explanation of how you're going to call this data via API. And then go down to, so you got auth with password and all that stuff. It's great. But you want to do OAuth 2. If I had just activated Google, for example, then I will want to have a look at this and get, provider Google and fill in all this data. You might need ChatGPT to help you with it. Have a look at their API docs to see all the different parameters that you can have in there. And that's the way that you can get your token back that you need for for successfully having this OAuth work, being able to retrieve data from Google. So all set up for you. The code is there, and essentially all you're doing is copy pasting this in, because we've already, hang on, do we need to import? Or did I import in the head code? No, I didn't even need to import. I just do this. I just do PocketBase.js, and then within the functions, I'm able to just reference that code that we saw on GitHub, which is just creating that PB object. And then afterwards, you're going to be able to run this whole PB thing with pb.collection users, and all this stuff will work within your Noodle application because you've imported that JavaScript, and so you have access to all of these different methods that you can use on the PocketBase SDK object. So let's just do a simpler example and look at how we could have created a collection, which I created one called orders, which just comes up with an ID by default. So I've added order number. I added text just because I was playing with it. It automatically has created and updated, of course. And we can sort of toggle views, we can search, filter, and we can edit this. So when you create the record, when you create the class, the collection, you're going to see this collection parameter screen. You can create fields so far, and remember this is like very early days for PocketBase, so they might add more types of fields, but this is already pretty good. You have your string fields, email fields is pretty good, I guess, for having something that's a bit maybe validated for emails, make sure that it's a real email. Integers, booleans, date, time. Select is pretty cool. It means you can set up like, what is it, enum, the enum field, so you can have like specific values that the user can choose. So this could be like roles, for example, role admin, role user, role guest, something like that. Files, because PocketBase can actually store files and serve files as well, which is pretty fantastic. So you can actually upload files and use it as a bucket, and it'll store them just on the server in one of the folders, what you saw earlier in the folder where you've unzipped your PocketBase project. And so you can actually have uploads in there, stored in there, and then store images, store whatever you want to files, which I thought was pretty cool for something so lightweight and simple. Relations, of course, because it's an SQL database, and so you can have one-to-one relations or many-to-many or whatever with a certain other collection, or JSON, of course, because we all love a good JSON. So this is already really cool. I'm going to remove this. So you have other options as well, like you can say that it's non-empty, that it has to be a value. I don't know what presentable means, whether the field should be preferred in the admin UI relation listing, default auto, whatever. So we can just remove that. You can also restore fields that you delete by accident. So that is all cool. I don't know what indexes is. So this is all stuff for fancy SQL people, and I'm not one of them. So maybe you know how to make indexes and how that helps database searches and all that stuff. I don't know how to make that work, so I'm not going to show that. And anyway, we're just sticking with the basics here. Seems like you could duplicate collections. That's pretty cool. Anyway, so now we've got ourselves a collection. The first thing we need to do is open it up, because the API, every collection by default, the API is locked to be only admin accessible. So we can't use any of this cool stuff yet to query the database, because in our options, we have a field called a tab called API rules, and it'll say admin only at the beginning. You got to click into it to give it a rule, and you can leave the rule empty if you want to just have public access. So at the moment, I've got public access for everything just for testing, but you might want to do one of these options. You might want to say that from the request that's coming in to create, we're going to check the user's ID. So auth is like the user object, I think. We're going to check the user's ID and make sure it's equal to, and then like say what it's going to be equal to, like collection dots created by or something like that. And you just set it up like a JavaScript expression. So as long as this JavaScript expression evaluates to true, then the person will be able to do what they're asking to do. So you could get crazy and creative with this and say like, say not the user who created it, but let's say the request.auth belongs to team equals the team reference on this particular order or something like that. So you can have as much complexity as you want here. I have a feeling that ChatGPT could probably write you a really good rule if you're not comfortable doing that yourself. So just see how you feel about that. But for just testing purposes, leave everything open, and it'll mean that you can access the API for testing it out. So that's what I have for orders at the moment. One really cool thing, by the way, with this is if I had set up, and I thought this is really important to mention because a lot of people ask about this, and I like this as well. Say I have a belongs to user field for whatever reason. I have a single user it's pointing to. We'll save that. This will store the relational key that points to the user that is related to this order. And if I want to query the user, I can use the expand. So in the query, there's like your parameters that you can use in the query. You can use expand, and expand is like in Noodle's backend. We use include in parse. You use include. It means that a related field, it'll return the data not just with the key from the related field, but it'll return the whole object. It'll go and query that related field and return you the order object and the user object as well. And even cooler than that, which is something I don't think we can do with parse, is that you can actually query sub-related fields. So if the user had a related field profile data, and that's pointing to a table profile data, then I could go, expand user belongs to user dot profile data, and it would return the profile data object as well as the user object. So you can add as many things in here as you want and go nested data, which is very cool. It's something I haven't experienced since the bubble days, where we could say, this records X related fields, Y related fields, Z related field, and you could go as deep as you want. Actually, in Bubble, you didn't have any choice. Kind of always returned, I think, or something. No, didn't always return, but you didn't really have a choice when you could choose take the data or not. It was all built into the search system. Whereas this way, you could actually specify what related data you want to have in there, which I think is really cool. Definitely worth experimenting with. And then, of course, you can have the fields that you want returned as well. You can get specific about what you want returned, but it's pretty simple, pretty nice. I like this a lot. This is just for viewing a record. Yeah, if you wanted to list search records, obviously there's ways to do it where you can get like pagination, and you can have 50 first page, 50 records. You can get all orders if you want, or you can do a specific query with like a field equals whatever. So you set these up yourself, copy paste them, and then set these up with the field names, inputs dot whatever, to be able to get something specific. And then of course you've got all your data all your parameters that you can use. So definitely worth having a look at this. And then a really cool thing that we're going to experiment with today is real time. So real time does a WebSocket subscription to the a particular collection with particular attributes. So you can actually add specific attributes to it. You don't have to subscribe to all records at the same time. You can subscribe to specific records, and explains how to do it, I think, probably in the docs somewhere. But for this experiment that we're going to do today, I'm just going to subscribe to all records. I'm not going to have any specific records. But yeah, you could subscribe to a specific record, and then that would return changes to the front end anytime that record is changed in the back end, which is great. So I think we've gone through pretty much everything. You've got logs, which is great, looking at requests, how many requests are going in, and how well it's dealing with them, who it came from, how the auth worked, all of that stuff, all that good stuff. You can see that it's coming from localhost 8574, which is the front end that Noodle uses, the port that the Noodle front end uses. And so that's awesome. You can change the log retention to a certain number of days to reduce the log file size, which was already getting quite big. And that's everything on this side, I think. You can also add new records manually, of course. Oh, by the way, one final thing that really made me just think that this is a tool for me. They have a rich text field. Like, why a rich text field? It's handy if you want to add your own specific data, in here, and be able to visualize it as rich text. and it's using tiniest, which is my favorite text editor in the world. And I've tried a lot of text editors, and I don't need to explain why. I have, but this is just amazing. I love tiniest. It is the best. It's just a wonderful, simple text editor. Just does what it says on the tin. You can upload images, links, create tables. It just is wonderful. Code blocks, or you can have a look at then what the source code is, what that's going to produce in HTML. And I imagine that what's actually saved into the field in the database is the HTML output of tiniest, which is cool because then in theory you can pull in HTML to it. So you could have a tiniest editor in your front end that's outputting HTML. You're saving it to this rich text field, and if you need to, you can go into the database and browse the data and see that data displayed in rich text, which is lovely. If you open it up. So just, yeah, wonderful. Oops, better just close that for a second. Okay, how do we do this stuff in Noodle then? What have we done? So what we've done so far is we've added it to the head code. We have gone into our API preview. We've gone to list search, for example. We want to just list all results, all records, and sort by created date. And so here we are with our fetch all records function. So just there's probably a way of like making this generalized so I don't have to do it in every single one, but I don't think so, because I think Noodle functions don't seem to work very well with taking like global variables like PB, for example. But there's probably a way to do it, and I'm just not very good at this. So I just put the PB variable at the top of each function. And then I copy pasted what you just saw there in what they were showing. I want to actually do sorted by created date. Do you have to put a plus, or I don't know? We'll find out. I want to sort it in the other direction. And then the outputs is the records that we've just got there from this async function that gets the orders, gets a full list of orders. And so when we create, it's the same. I got it from the API documents. And I just substituted where they had like order number. So they give you the fields, by the way. So when you go to create, they give you the fields. So they show you the fields that you have in your database. You just copy paste that in, replace this stuff with inputs dot whatever or a variable, and then do the async function at the end to create the data. So that's pretty simple, pretty awesome. What I'm doing is when the page is loaded, I'm fetching all the data. When I click a create order button, I'm running that function with the order number. It's just because it's for testing out of this input. And the records are going into an array called all orders. Now I don't use the array to fill the repeater because we're going to be pushing records to the array because it's just a really simple example. We're not using the Noodle insert object into array. So the array is set up with a listener where that insert objects node is going to trigger the listener and trigger the array to update and therefore trigger the repeater to update. But because we're just using a simple JavaScript push function in here, so I'll show you this in a minute, but we're just using a simple, oh no, sorry, we're not even using a push function. We're just adding the record to the end of the array. So this like internal data manipulation isn't going to trigger the React part of Noodle to do any data updates. So these things are built into the React system. The array and insert object into array are built into React. So when you do them, it refreshes the data in the front end and shows the update. So we're not doing that for this example. So what I'm doing is when an order is updated, I'll show you how this works in a second. I'm just taking the existing array and I'm adding a record onto the end of it. And then I'm mapping that new array to the old array. And it's a hacky way to get it to output the new array as something unique that then the repeater will say, oh, there's a new array. I'm going to list the data from this array. So it's not the best way to do it, but it works. And then the all important live data function, and this is where our update orders gets its stuff from. This is just taken straight from the API docs, which you can see. Where the heck is it? Here. So I've said that I just want to subscribe to everything. So I just copied this part. And what that's doing is on page load, then it's subscribing to the orders collection. So any action, delete, update, create, whatever, is going to trigger the record that's just been updated to be returned to this function. And so it creates an event listener. And if we put up like this, then we're going to see when we create an order, then this function receives that message because it's been subscribed already. It receives a message from the database, like a webhook almost. It's WebSockets. It's saying that it's created something and it's given me the full object of the record that it's created. So you have two outputs, action and record. So action is going into a new function and record as well. This new function reacts every time there's an action coming in. It says if the action was create, then update that orders array and output that. If the action was delete, that's the only ones I've got so far, update the orders array and output it. So then we're not, because what we don't want to do is we don't want to be calling the fetch all records every time. Like you've seen in my other videos, that's bad practice. We don't want to do too many API calls when we don't need to. We already have all the data we want on the front end. So why not just, if we start creating lots and lots of orders, then we don't want it to always be fetching every time so that it's always, it's going to start returning 7, 8, 9, 10 different results when it already has 7 of the 8 results already stored in the front end. So rather we use the array to store it in the front end and then just push an object to the array every time we create a new order. So there it is, our new, ta-da. Okay, and then the delete function works the same way. You can see here, it's going to output delete with the record that's just been deleted. So delete these ones that don't have a number, for example. You can just see it updating immediately every time. So because it's a WebSocket, it's instantaneous. And like they said in their in the PocketBase documentation, they boast that they can have 10,000 concurrent connections. So this is a super lightweight, low cost backend that can be run for small to medium projects that can be very easily integrated into Noodle. We can just create a whole bunch of prefabs for Noodle that have create record, update record, delete record, and with all the different options. And you just put in what your class names are, what your fields are in those classes, and then use that as a way to work with your data in the editor of Noodle without anything else. That's it. You just got your backend set up completely. This is a working app based on one backend and the Noodle front end. So that's cool. What I would say, repeating what the guy from Fireship said, is the disadvantage of this is because it is running as a singular entity. It's not something that you can kind of duplicate and run on different cluster and like in a cluster. It's storing all the data locally. It's in SQLite. So the disadvantage of that is that you will not be able to scale horizontally. You're going to have to scale vertically. So if your app starts getting used more and more, and you're on your 1 gigabyte of RAM, 1 CPU server, you're going to have to notice. So you're going to have to do DevOps. You're going to have to see when that server is being too solicited, so that it's starting to crash or slow down, and so the data is returning more slowly from to the front end. You're going to have to take care of that by upgrading your server to 2 CPUs, 4 gigs of RAM, or and on and on and on. And so, what is the disadvantage of that? Well, if you have spikes in activity, this is the classic problem that was there before AWS and all this like cloud stuff. If you have suddenly, you have 100 users a day, and then suddenly you have a big promotional event and there's 10,000 users come on your site, then they could crash your server unless you upgrade it to a higher paid version server. But then you're going to pay more for that server tomorrow when you only have 100 users again, and you don't need that big server anymore. So you have to downgrade it again, and upgrading and downgrading servers brings it offline every time you do that. So it's definitely not ideal. I've seen some people who've talked about ways that it can scale horizontally using other kinds of tools, and I'm sure that's going to come more and more. And if PocketBase becomes popular, which I think it should, I like it. I'm going to be using it for some of my side projects. But that question of vertically scaling is one that puts a lot of people off. Oh, I can't put it into App Runner and make it sort of spin up containers spontaneously when I have lots of server traffic. No, we can't do that at the moment with that I know of with PocketBase, but correct me if I'm wrong and point me towards videos where there's other systems that could be used to help it to scale. But that's, it's not a deal breaker either. Because if you have an app that's really only just a side project and it's going to be used by like, it's a local shop or something that's going to be handling like maybe 50 people a day or 100 people a day with your successful shop, then you're not going to have to worry about this. If you protect it from being hacked and DDoS and all that kind of stuff, then it can be you probably will never have a problem with it. But if you're planning on scaling and going, putting out a big promotional event, and there might be like 10,000 users suddenly descend on your app to check it out and see what it's all about, then that might crash the whole app. So that's that sort of DevOps question, which I do think is actually worth the hassle. And I'd rather have my app slow down and have to have to do the DevOps and have to upgrade it the night before the big marketing event to twice as powerful server because I don't want it to crash. Or just spring for the extra $20 a month and just get those extra 4 or 5 gigabytes RAM. 20, I'm on a server with Contabo, and it's a German hosting provider, and it's like 24 gigs of RAM, and I can't remember how many, 8 CPUs, something like that, and it's like $40 a month. So really you can get a very hardcore server. I call that very hardcore. People will laugh, but you're talking those tens of thousands of people could be handled by a 24 gig server running PocketBase. So that is a solution. You could just spring for a little bit extra money to make sure that you're always covered, and you're only ever using 2% of the capacity of your server, and one day it goes up to 50%, but at least you got it covered. So that's just something, that's one of the more important things to think about. That's not the same with things like Supabase that runs on Docker and that can be connected to external databases and spin up multiple different Supabases on the same database to handle lots and lots of requests. So that's it's a question that is worth keeping in mind. But I hope you've enjoyed this demo of how PocketBase runs and how blazingly fast it is. We're on localhost, so like whatever, don't give me any grief about that. But it's working really simply, really lightweight in the front and in the back. You're talking something that's 40 megabytes and a node file, node module that's like, how much was it? 1.5 megabytes. So like we're not talking huge stuff here in terms of like having an entire backend at your fingertips. So I hope you've enjoyed it. I hope you play with it yourselves, and good luck with your own experiments.